So I've got the terminal side passing through -4, 1, and passing through -4, -1. So I got two little triangles here. So I have this little triangle and this little triangle. So unlike number 1, they were not nice this time. It is not a Pythagorean triple. So I need to find my radius. How am I going to find my radius?
What?
I need to find my radius, or my hypotenuse. Yeah. So I'm going to use the formula that we talked about, that we've been talking about, or you can just look at it and use Pythagorean theorem. 4 squared plus 1 squared equals r squared. So that's 4 and that's 1, the legs of my triangle, so the hypotenuse is a squared plus b squared equals c squared. So 4 squared plus 1 squared, that would be 16 plus 1 equals r squared. So r squared equals 17, so r equals the square root of 17. All right, so sine is y over r, so 1 over square root 17. You can't leave it like that. We have to rationalize. So I've got to multiply both the top and the bottom by square root 17. So that gives me 1 times the square root of 17. So I'm just going to write it as square root 17 over 17. Cosine is x over r. So I'm going to do 4 over square root 17.
Woman, do you have kindergarten class?
I do, second period. I can't leave it like that, so I'm going to have to rationalize it. So multiply both the top and the bottom by square root 17. And then hold on, I have the second.
What?
You only like me from the start.
There's the second part of that.
I don't know who you talk to like that. I'll catch you first period next month.
What is second period?
Stop.
All right, so I got 4 squared 17 over 17.
Freaking writing on that.
Tangent is y over x, so it's 1 over 4. In quadrant 2, what's positive?
Quadrant 2.
Sine. Only sine is positive, which means my other two need to be negative.
Yeah. What's that means?
And for B, which is in quadrant 3, it's the exact same ratios because it's the exact same triangle. So I don't have to recalculate all of them. I'm just going to copy them down. Square root 17 over 17. 4 square root 17 over 17. And 1/4. But in this quadrant, in quadrant 3, what's positive?
Nothing.
Tangent. So sine and cosine are negative. All students take calculus. That's where the things are positive. It's not hard to remember. All students take calculus. That tells you where the things are positive. They are all positive here. Student stands for sine, is positive here. Take stands for tangent, it's positive here. Calculus stands for cosine, that's positive here. All students take calculus. It is not hard to remember that. If you can't remember that much, then you probably have some serious memorization issues and you might want to see a physician about your memory. Okay, so
On
number 2, which ratio do they both share exactly? Has to be exactly the same. Sine, cosine, or tangent? Okay, well, we'll look at them one at a time since y'all are having trouble. Sine A is square root of 17 over 17, where sine B is negative square root of 17 over 17. Are those the same? Nope, one's positive and one's negative. Cosine is negative 4 square root of 17 over 17. Cosine of B is negative 4 square root of 17 over 17. Are those the same? Those are exactly the same. That's what I asked. Which ratio has exactly the same answer? So it's cosine. So this time, we're going to use cosine to find our angle. I'm going to write it with cosine theta since they're both the same, so I don't cause any confusion. Cosine of theta equals negative 4 square root 17 over 17. And I want to find theta. Not cosine theta, but theta by itself. How do I get rid of cosine? Inverse cosine. So I'm going to inverse cosine the left-hand side to cancel out the cosine, which means I have to inverse cosine the right-hand side as well. And that's what I'm going to put in my calculator to find theta. Inverse cosine, negative 4 times the square root of 17 over 17. And I got 165, I'm going to write it as 166. It's 165.96, so theta equals 166 degrees. Now look at the two angles you have and think about them from standard position. Starting over here at the initial side and opening up this way. Which one is 166.6, A or B? A. Because A is above 180, so it has to be A. So angle A is 166. Is 166. What about B? How am I going to find B?
Subtract it from 360. Wait, which one? B is like all around it, right?
Yeah, that'll work.
So wouldn't this be like?
So it not subtract it from 360, but if I go around the opposite direction, that's going to give me a negative angle. So couldn't we say, just curious, isn't this negative 166 if I go this way? Right, it's the exact same. It's a reflection of the one on top, so it's negative 166. So if I add 360 to that, that would give me the positive version. So I'm going to take that 165, I'll just make it negative 166, and add 360.
194.
And you get 194. So this one, angle B, equals 194. And yeah, there's a bunch of different ways you could do it. I could also do 180 minus 166, get what my leftover is, and then do 180 plus that and get the other piece. However, you need to do it, but this is the like simplifying way to do it. So here we go. New triangle. All right.
Take the reference table and add it to 180.
All right, here's my two triangles this time. They did not give me a hypotenuse, so I have to find it using Pythagorean theorem. So negative 1 squared, that's this leg, plus, square root of 3 squared, that's this leg. That's going to give me the hypotenuse squared, which we call it r when we're doing rotation angles. So that's 1 plus 3 equals r squared. So r squared equals 4, which means r equals 2. All right. So sine is y over r, so square root of 3 over 2. Cosine is x over r, so 1 over 2. Tangent is y over x, so square root of 3 over 1 is just square root of 3. In quadrant 2, what's positive in quadrant 2? Sine. So the other two are negative. These three, it's the same triangle, just in a different quadrant. So your three ratios are the same. In quadrant 4, what's positive? Cosine. So that means everything else is negative. Looking at my ratios, I'm looking for the one that is exactly the same. This time it's tangent. So I'm going to write tangent of theta equals negative square root 3. I'm trying to solve for theta. I need to get theta by itself, and right now it has a tangent with it.
Inverse.
So I'm going to inverse tangent. Good. right, that leaves me theta equals my inverse tangent square root 3. Negative 60. So I got theta is negative 60. So which angle is that when you look at your picture? Negative 60. Is that angle A or angle B?
Yeah.
It is, angle B. This is negative 60. So angle B equals negative 60. Now, before I move on to find angle A, which I'll do in just a second, it is angle negative 60, but I would also like to know what is it if I wanted it in positive. I wanted the positive coterminal angle. So, so 300, because you add 360 to negative 60. All right, what about angle A? So if this was 60, I want this one.
Can you just add 180 to it?
Yeah, you can add 180 and get angle A. So angle A equals 120. All right, now, when we have a grid to look at, when we have the coordinate plane to look at, and we have the actual drawings on there, sometimes it's easier to just do, like, some of you can just kind of calculate in your head by looking at what you need, but we won't always have that. So these are actually the patterns that you're going to use. When you're using sine to find an angle, you do inverse sine. Your calculator is going to give you your theta, and if it's not the theta you need, then you're going to do 180 minus what the calculator gave you. That'll give you whatever's in quadrant 2. If that's not what you need, you're going to add or subtract 360. Notice this n right here. This n just means you can add 360 as many times as you need to, because these angles go around and around and around. So that's what that n is for, however many times you need to add or subtract 360. If you have cosine, the calculator is going to give you one of them, and then you can make it negative, or you can just add or subtract 360. With tangent, it's never adding or subtracting 360. Tangent is always adding and subtracting 180. Later, when we get into the graphs of all of these, that'll make sense to you and you'll understand why. We're going to keep these notes because you're going to need them, but you won't need them tomorrow because tomorrow you're going to work on your project.